Alright, today we are going to be talking about comparing rational numbers. So we've already compared integers. Now we're going to be looking at rational numbers. So first off, what is a rational number? A rational number is any number that can be written as a fraction. So this is talking about any terminating, any repeating decimals, and any fractions. Okay? So how do we do this? What are the steps to comparing? We are specifically just going to be looking at two numbers here. So first, we want to look at these two questions here, because sometimes if one of these are true, then we don't actually have to do any computing here. So first I'm going to ask, are the signs different? If you have a positive number or a negative number, you should know right away that positives are always bigger than negatives. You can also ask yourself, are the whole numbers different? Because if the whole numbers are different, then you don't have to worry about the decimal or fraction part. But if neither of those questions applies, then you're going to move to step 2. What we are going to ask you to do is to turn every single number into a decimal. Obviously, if you know how to do it differently, that's fine, but this strategy really helps to make it a little bit easier. Once you've converted to a decimal, we have to make sure that they have the same number of decimal values. So we're going to add zeros, if necessary, to the right of the last digit, so there are the same number of decimal places in each number, and then after that we can just compare the numbers after the decimal point. So let's look at a couple examples. Alright, so comparing the following numbers, we are asking you, this is very important, you are not going to get credit unless you are showing work to prove your answer. Okay? So let's look at this first one. We've got -3 and 1500ths and 3 and 2500ths. So the first question we said to ask ourselves, are they both negative, are they both positive, or are they different? So we've got a negative number here and a positive number. So I actually don't have to do anything other than comparing that this is a negative and this is a positive. So that's how I want you to show your work. So we know that every single negative is going to be smaller than a positive. So -3 and 1500ths is smaller than 3 and 2500ths. Okay? Alright, looking at example 2, we have 5/8 and -7/12. So I could go and compute those, but what I'm going to ask myself first is, look at their signs. This one is a positive, this one is a negative. They are opposite signs. I'm going to identify that by writing that we have a positive and a negative. And then I know that positives are always going to be bigger than negatives. So 5/8 is greater than -7/12. Okay? And this is how you show your work for that. Alright, number 3, 2 and 5/6 and 3 and 3/12. So first, if I look at that, are they opposite signs? Nope, they're both positive, so I know I can't use that to compare. But the next thing I'm going to look at is the whole numbers. So I'm actually going to use my highlighter, and I'm going to highlight the 2 and the 3, because I notice that they are different whole numbers. So actually, because I did that, I can ignore the fraction part, because that doesn't matter. They've got different whole numbers. So really, all I'm comparing here is 2 and 3. 2 is smaller than 3. It's less than 3. So 2 and 5/6 is going to be less than 3 and 3/12. Example 4. We've got -5 and 8/10ths, and then we've got -3 and 841 thousandths. So first I'm looking at the signs. Are they opposite signs? We've got a negative and a negative. That does not apply. Next I'm looking at the whole numbers. If I actually highlight the whole number part here, they are different whole numbers. So I don't have to worry about the decimal part. I'm just looking at the whole numbers. We're comparing -5 and -3. Now remember, a bigger negative is a smaller number. So 5 would normally be bigger than 3, but since it's a negative, it's the opposite. It's actually less than -3. Alright, number 5, we've got 3/10ths, and make sure you're paying attention to that bar over it. That means 3/10ths repeating, and then we have 3/10ths here. So first I'm looking at the signs, they're the same, can't use that. Then I'm looking at the whole numbers are the same, so I do have to compare the decimals. Right now it looks like they're exactly the same, but that bar up there is really important. So what I'm going to do to show my work underneath is I'm going to rewrite this, and I'm going to add another decimal value. When we have the bar over here, the next decimal value isn't a 0, it's actually a 3, because it's 3 repeating. With this, we're just going to add a 0. So now we have the same number of decimal places, and we're going to compare. So I'm comparing 33 to 30, and it's positive, so 33 is bigger than or greater than 30. So 3/10 repeating is greater than 3/10. All right, number 6, negative 2 and 73 hundredths, and negative 2 and 734 thousandths. So again, look at the signs. They're not opposite, so I can't use that. Look at the whole numbers. We have negative 2 and negative 2. They're the same, so I have to look at the decimal part. Right now, they don't have the same number of decimal places, so I'm going to rewrite this underneath, and I need you to be rewriting it to prove your answers. And then I need to make sure they have the same number of decimal values. So this has 2, this one has 3. So I need to add a 0 here so that they both have 3 numbers after the decimal place. Now remember that we're looking at negatives. So normally 730 would be less than 734, but since it's negatives, it goes in the reverse way. It's actually greater than. So negative 2 and 73 hundredths is greater than negative 2 and 734 thousandths. All right, number 7. Again, first thing we're looking at, do they have opposite signs? Nope. We look at the whole numbers. There's nothing written here, which means the whole number is 0. That whole number is 0, so we do have to compare. Now, we don't have 2 decimals, we have a fraction and a decimal. As we said, we think it's easiest if we convert everything to a decimal. So 3/4, maybe you know what that conversion is by heart. If not, you can either use your calculator and do 3 divided by 4, or you can use the conversion chart that we gave you. When you use that, you should see that 3/4 is equivalent to 75 hundredths, and then I'm just going to rewrite 7/10. Now that they're both decimals, we need to make sure they have the same number, same amount of values after the decimal point. This has 2 numbers, so I need to add a 0 so that it has 2 numbers. Now I can compare. We're talking about positives. 75 is bigger than or greater than 70, so 3/4 is greater than 7/10. Number 8, we've got 0 and 87 hundredths, and then 0 and 8/10. Looking at the signs, are they opposites? Nope. So we have to compare there. Look at the whole numbers, they are the same. So we do have to look at the decimal value. I'm going to rewrite them so that I know that they have the same number of values after the decimal. This first number has 2 numbers after, so I'm going to add a 0 here. So I'm comparing 87 and 80. 87 is greater than 80, so 87 hundredths is greater than 8/10. Okay, last 2. We've got negative 2/3 and negative 5/6. So negative 2/3, negative 5/6. First off, we're looking, are the signs the opposite? Nope, they're the same. And then the whole numbers. There's no whole number part to it, so it means the whole numbers are both 0, which means we do have to compare. We think it's easiest just to convert everything into a decimal. Again, you can either plug this into the calculator, do 2 divided by 3 and 5 divided by 6, or you can use your conversion chart. If you use that, you're going to see that negative 2/3 is negative 6/10 repeating, and negative 5/6 is negative 0 and 83 hundredths repeating. So now that we have 2 decimals, we need to make sure they have the same number of decimal values. So this guy has 2 numbers after the decimal, this one only has 1. So we need to add another value. Remember, this repeating bar means that it's not a 0 afterwards, it's a 6 after. So now we're comparing 66 to 83. Normally, 66 would be less than 83, but since we're talking about negatives, it's actually the opposite. Negative 66 is going to be greater than negative 83. Last one, and then we're going to have you work on the you tries. We got negative 6 1/2, or negative 6 5/10, and then negative 6 1/2. So we're looking at the signs. They are both negative, so we can't use that to compare. They have the same whole number, so we do need to convert. This one's already a decimal, so I'm just going to rewrite it. And then -6 1/2. Again, use your conversion chart. 1/2 converts to 5/10. So now we got to make sure they have the same number of values after the decimal. They both have one number. If we look at it, we have 5 and 5. They are the same, so they are equal. Go ahead and do number 11 and number 12 on your own. Make sure you're showing work to prove your answer.